Hi students, my name is Sakesh Shetty from AJIT Engineering College, Mangalore. Today module 4 will discuss about impulse turbine and reaction turbine. What do you mean by impulse? Impulse is the name, it comes from that impact force, because when the water is comes from the nozzle and it will in the water will strikes with high velocity, that reasons that force, that is called impact force, that reason they are calling impulse turbine. So what happens, how it will works is, means you can see best example for that, when fire extinguisher, in that they are using one big nozzle, one pipe, that why it means the water is splash for long distance. So that reasons they are using that fire extinguisher and big nozzle pipe. So that force is very much high velocity, so that reason nozzle is connecting. This is the one example. This is a dam and reservoirs is connected, general layout of power plant. So here the penstock pipes is there and nozzle is there. Nozzle, why we are using that, pressure energy will create and area will decrease. In that time what happens, water is comes out in high velocity. When it's velocity is, water is comes under in high velocity. The best example for this one, Pelton turbine. The name itself, they're written that Pelton turbine means the name, the scientist name Pelton, and he found that Pelton turbine. For example, the Maharashtra one Koyna river is there, Koyna dam is there. They are using that and Pelton. So this is the one runner, and this is the buckets connected for that runner. So when water is strikes that bucket, automatically runner will starts to rotate. So it will start to rotate again their circumferences. So when nozzle water is come out and strikes the bucket, what happen, and actually it increase the pressure energy to kinetic energy. Uh, uh, See, this is the for example, this is the one Pelton when the water is flowing inside the pipe is in pressure energy, and when it's come out that it's in kinetic energy. I will show you that neatly, that diagram. So this is the one Pelton penstock pipes. The water carry from upstream to downstream side. So upstream, the water is storage in an upstream side, and then water is carrying from the upstream to downstream side using this pipe. So this is the water strikes and releasing from that pipe nozzle, and it strikes the bucket and it starts to rotate. When it's rotate, then that point is called runner. So this is called runner when it starts to rotate. So this is the head from top of the reservoir to center of the penstock pipes. So that is called head. Head we can convert it for pressure also. This is head. So we can, this is equal to storage of water. Water is carrying from this penstock, and from here to when it comes out from that nozzle, then it strikes the jet in between the edge of the nozzle to strikes the bucket. That is in that time the pressure is constant in, and it will be the atmosphere pressure, and the water is converting from pressure energy to kinetic energy, as I told you before. So next, then jet strikes the bucket, it will starts the rotate, and another bucket will come in that place, and the same time it is series of bucket. So one by one the bucket will water will strikes that different buckets, and it will starts, and then it is convert hydraulic energy, mechanical energy will convert, and then electricity will generate. This is the general working principles of turbine actually. So that as I told before, that Pelton he found this impulse turbine. So that is the best example is Pelton turbine. So this is the dams, as I told, that water storage in the upstream side, water is from upstream to downstream side. So then after it's start to rotate, and it will rotating, and then it will convert to electric. It means the shaft is connecting here, then there is one motor is there, here one motor is connecting for that. So automatically electricity will generate using this method. This is the technique, general techniques. What is the impact? What mean impact? As I told, no, that water comes out to the nozzle and it strikes the bucket. That is called impact in high velocity. So that reasons that is using impulse turbine. So that velocity is very high, and the pressure is constant. And before coming to that nozzle, the water is flowing in the pipe, that is in pressure energy, then it's converted to kinetic energy, and all the pressure energy is converted to kinetic energy. So then the edge of the nozzle to the bucket strikes, in that time pressure is constant. So, strikes the bucket, so that in distance, that is an atmosphere pressure. When it comes from the nozzle and it strikes the bucket, that pressure is constant, that pressure will not change, that is called atmospheric pressure. So pressure is constant. This is a concept of main turbine. So pressure will not change. That all the pressure, it's converting its kinetic energy, and it is nozzle is in providing, it is decrease the area and it increase the velocity. So when what why that portions, what I said, no, it will strikes the bucket, and that portion and pressure is constant, that high velocity, that is called impulse turbine. That force is in very impact, the high velocity, and the pressure very high velocity and high pressure. So that reason they are calling it impact, the force is very high, that is called impact. So that reason only it will start the rotate. This is the concept actually, that impulse turbine concept. And what do you mean by reaction turbine? In that reaction turbine, why we are calling the reaction turbine? Here two types is there. One is Francis, the name itself they are given, the scientist name is Francis, so he found the Francis turbine. And second one is Kaplan turbine. The difference between Francis turbine and Kaplan turbine is these two are comes under in the reaction turbine. So the Francis turbine, the flow is moving in a radial direction, and in the radial direction, runner is there, and that the water flow is in radial direction, it will rotate. And Kaplan turbine, the flow in water flow in axial direction.